All right, folks, here we go again. We're going to take a look at the process of dilution. And basically, dilution is the process of making a solution less concentrated, okay? So it says this usually is done by adding more solvent, okay? So let's think about if you have some juice and you take some juice and you water it down with some water, okay? You are making your juice more diluted, okay? In the process of making it more diluted, you are making it less concentrated, okay? Because concentration and dilution are opposites, okay? So this question here says which of these solutions is more concentrated, A or B? Basically what this is saying is which one has more solute per given amount of solvent. So if we take a look at A, we can see that we have all kinds of solute particles in this small volume, and B has a larger volume of solvent with the same amount of particles. So the one that is the most concentrated is A, and the one that is the most dilute is B. So it says we use molarity in dilution problems as it's the most common way to express concentration. When we add more solvent, we are decreasing the concentration of the solution, which decreases the molarity of the solution. And lastly, it says this makes the solution more diluted. All right. So basically, if we decrease the molarity, we're decreasing the concentration, and that makes something more dilute. All right. So let me erase this, and we're going to take a look at a problem. Looks like I may have just erased it on my own, which is fine by me. Our formula for this looks very similar to Boyle's law. If we remember Boyle's law from way back when, okay? Remember Boyle's law was P1V1 equals P2V2, and the 1 represented the original volume and pressure, and the 2 was the final volume and pressure, all that fun stuff, okay? Well, we call this the vmvm formula because we've got V1M1 equals V2M2, where V1 and V2 are our original and final volumes, and M1 and M2 are our original and final molarities. Okay, so this is, I think that these are a pretty easy problem. Um, all we're doing once again is just plugging and chugging. So what we want to do is we always want to look for what we have in the problem. So let's take a look at this example. What's the molarity of a solution of ammonium chloride prepared by diluting 50 milliliters of a 3.79 molar ammonium chloride solution to 2.00 liters? Well, we know we need to have a V1, an M1, or an original volume and molarity. We also need a final volume and a final molarity. So let's see if we can find those items in the problem. So it says, what is the molarity of a solution of ammonium chloride prepared by diluting 50 milliliters and 3.79 molarity to 2.0 liters? Okay, so if we're going from 50 mils to 2 liters, the 2 liters is our final volume. All right, so I'm going to plug that in for my final volume, 2.0 liters. Now, a lot of y'all are probably already noticing that my original volume and my final volume have two different units. This one's in milliliters, this one's in liters. Just like in the gas laws unit, I have to make sure that my units match up. So what I'm going to do is I need to convert one or the other. Okay, since I've already written down liters, I might as well convert 50 milliliters to liters. I know that I can just divide it by 1,000 and get 0.05 liters. Okay, so now do I have an original molarity? I do. Okay, the molarity that goes with 50 milliliters is 3.79 molar. And I'm looking for my final molarity. I'm looking for M2 because it says what is the molarity. So let's go ahead and just plug that into our formula. V1M1 equals V2M2. So I have 0.05 times 3.79 equals 2 times M2. Well, if I want to get M2 by itself, I'm going to divide both sides by 2 and plug that into my calculator. I should have done that before we started, but I didn't. I can crank that out pretty quick though. 0.05 times 3.79, enter, divided by 2, enter, and I get 0.09, let's see here, 3 sig figs, so 0.095 molar. And that's how you do it, folks. Really not bad at all on this kind of problem. Okay, almost all of them are going to say almost all of them are going to fall into this V1M1 equals V2M2 formula. Okay, so why don't you take a look at 12-36 on your own, see what you can come up with, and we'll check that answer tomorrow in class.